Greetings from the sunny Singapore. So I'm Tio Baguio. I'm a solutions engineer here at HashiCorp, and I help customers understand our products better. So lately, I've been asked by various customers, how do I go about implementing service catalog for infrastructure provisioning? How do you make Terraform a part of the automated process, deployment process? How do you integrate with Jenkins pipeline, and what about Jira? So this session is to explain the Terraform API, and by the end of this session, you'll understand more about the Terraform API, its usage, the workflow, and I can even promise you that you will be able to write automation using this API and use it yourself. We have plenty of demos, sample codes available for you. And with that, I'm just gonna going right in. Before I describe this API, let's see the basic working for Terraform. All right, the core of the Terraform workflow has 3 steps: write, plan, and apply. So write is where you codify your infrastructure. You describe your infrastructure as a code using a simple declarative language, which we call HCL. The plan phase is the preview of the actions. This is where we answer the question, what would Terraform do to create or modify the infrastructure that you want? And the apply phase is when Terraform executes the actions proposed earlier in the Terraform plan. This is where the actual provisioning actually happens, right? So most people started using this workflow using the Terraform open source, because it's free, it's easy to download, install, being a single binary file. And normally all these steps happen locally in the developer's laptop. So the core workflow is further enhanced by a Terraform Enterprise. You can think of this as a control plane for the Terraform. So now we no longer have a single binary that lives on a developer's laptop. Instead, you have a new platform, right? And this collaborative model gives developers access to an ecosystem of tools, security, compliance, and you'll be able to scale across your organization. One thing to clarify that Terraform is available, Terraform API is available on these commercial versions. And there are 2 of them, Terraform Enterprise and Terraform Cloud. I use the words interchangeably, but just to be clear that Terraform Cloud is our managed service offering. HashiCorp is responsible for running the day-to-day management, whereas the Terraform Enterprise is a private instance that you own and you manage. Now, in terms of the API, it's applicable for both of these platforms because 95% of the parts are the same, right? When we put new features, we normally put them in the Terraform Cloud. So back to the core workflow, and I said it's enhanced by the Terraform Enterprise. Workspace is central to this. So in Terraform OSS, workspace usually means directory where you do that plan and apply. You no longer have this directory because now you have a platform. So the workspace is more like a virtual room. And inside that workspace, there are many things. You have state files, and these state files are basically physically encrypted. You have variables that acts as parameters to the actual run. You have a role-based access, notifications, various settings like version control system settings, and so on. There are also additional steps that we insert between the plan and apply, such as cost checking, policy checking. So the execution is enhanced in this platform. There are many ways you can use this platform, whether you're a single user or you work in a team or across the entire organizations. So these workflows basically UI-driven is the simplest. You use the user interface of that Terraform Enterprise or Terraform Cloud. Normally, you start with a workspace you created yourself, and then link that to a VCS repository, right? The run in this repo or the run in the workspace usually starts automatically when you merge or you create a new commit to the version control. For the CLI, this is more for the users or developers who are already comfortable with the Terraform command line. They run the CLI on a computer that they control, but the execution actually happens on the Terraform enterprise. So there's a second copy of the CLI that's invoked and controlled by the Terraform enterprise, and it is performing the actual operations. And then there will be, messages that will be printed and copied to the local run. So here the CLI is basically a front end, and the Terraform enterprise act as a back end. The API were the focus of our discussion today. This is where you have the most flexibility. It does requires you to create some tooling, and basically you decide when your infrastructure is code is ready, right? We call that also configuration files. So whenever that's ready or whenever the codes change, you need to determine that, and you need to fetch that configuration files, I think from the version control, and then upload it to the workspace. You also have a complete control when that run should occur. This gives you a lot of flexibility, but requires a little bit of tooling, but also means that you can work with the unsupported version control system. Let's talk a little bit about the API. Version 2 of the API is the thing that really powers the entire platform. It is comprehensive. It covers basically all the functionalities that you want to automate. All those things that you can do from the user interface, it can be done from the API. You can see the documentation on our website. It is a very comprehensive documentation and allows you to find what you need. The most important thing is it's stable, right? We guarantee backward compatibility, and specifically for those endpoints that are not marked as beta, right? And last, the API is consistent. We have a basically built-in JSON API specifications. So there's no ambiguity on what the response looks like on every single request, what error code you can expect given some kind of error state that you encounter, the detail objects, error objects, document structure, request and response headers, and so on. So basically, this compliance governs the behavior of a single request and response in the API. So now, how do you consume this API, right? So this is the typical interactions. Once you create your infrastructure code or that configuration files, you probably put it in a repo where you can collaborate, and then you kick off your pipeline. Presumably, you're using Jenkins or other CI/CD toolings. So the first thing you do is create space and then assign a ownership to that workspace. These two steps are basically optional. If the workspace is already created before, then you can just reuse it. But then, and then afterwards, you can set the variables. You can set what we call configuration versions and upload the code to this configuration version. So configuration version is basically a structure where you store your code, and it's associated with the workspace. And then after all that done, then you can kick off a run, and that would create a series of plan, apply, and anything in between that. So let's just show you what that that pipeline looks like, and that and how we can use all of this API, right? Before I jumping into the pipeline, let me show you, take a baby step first and show you, how to use the API, one sample of it, using a common kind of like tooling, which is here I'm using a bash and a shell script. Basically, the demo here is very simple. The script obtains a workspace identification when you give it a workspace name. So the first few lines here is just basically getting the arguments, right? The subsequent ones basically here where you specify your Terraform instance. I'm using a Terraform cloud in this case, and that is the address, and that is my organization. Now, all the APIs would need a token. We call that a bearer token. So this is this means that users' requests must be authenticated using this bearer token, right? And that's the header that you need to use. As I mentioned, we follow the JSON API, so the content type has to be formatted in this way. The endpoint of this API is a simple API, which basically you give the organizations, you pass it the name and the workspace that you want to look up and that you want to find the identification. Right. But a little bit about the token. There are user tokens. There's a team token. Then there's organization token. In order to run and apply, run and apply, you can only use user token or team token. The difference between them is that team token is only one API token at a time can be used, whereas the user can have any number of the API token. Now, as far as the return codes, you can expect 401 and when there's an authentication error. When you have when you don't have access to it, then you will get a 404, and the same thing when the resource do not exist, right? So I'm just going to run this. I have a workspace called VM instance. And then you can see basically the requests and then as well as the response, the JSON response that are gotten back from the Terraform. In this case, it's all about, all this data is about a workspace, and you can find the ID on the first line there. So that's a simple kind of example of the API, and there are many APIs that we can use, many endpoints. Your job is to compose all of these in order to automate your work, right? So let's take a look at that. I'm going to basically, here I have a pipeline that's going to make use of the various API endpoints, right? But before I execute that, let me show you the workspace basically that I have. Basically, I have a default project, and under that a couple workspace, VM instance and web instance. As I mentioned, there are a lot of things related to this workspace. Yeah, this one thing, I created this workspace and linked it to a version control system. So you can see the Terraform config file in there. So what that means that I can reuse it. I don't need to create the workspace and upload the code, the configuration files using the API, because it's already recorded in this workspace. I have various runs kind of perform before, and the state files also kept in the workspace physically encrypted, so it's a very secure environment. There are a couple of variables that I want to influence, or I want to set the parameters, and this will basically the user through Jenkins, they will have a opportunity to input the variables value for the VM name and also the type of the virtual machines, right? In this thing, by the way, the context is this automation is going to create a simple virtual machine. And then the rest is this is basically used for authenticating to AWS. And I think this is I make use of the dynamic provider or dynamic workload identity. And this is kind of like a separate subject in itself. But basically, you don't need to hard code your AWS identity anymore. Everything is going to be dynamic. And then we can, using this, we can go ahead and provision the infrastructure the way we want. Okay. So that's a little bit about my workspace. Let's go ahead to the Jenkins. You can see this. There are various stages. So let me show you the the configurations of that. So basically, I declare some parameters. In particular, the VM name and the VM type is something that users can choose to influence the provision, the infrastructure that we're going to provision. The code is going to be residing in my repo. So you can go to that repo, make it a public, and you can just copy that and study that yourself, right? But here, actually, let me just go through it quickly, and so that we understand what's happening in this pipeline. So this pipeline consists of many stages. The first thing that we do is we want to get a token from Vault. Being a good citizen, we do not want to have that API token hard-coded in this Jenkins pipeline. We want to store that centrally in Vault. So there is basically some configurations up here where I can point it to the Vault instance and tell Jenkins the path where I store the API token. Right. As I mentioned, I'm going to reuse the workspace that I've already created and link to a VCS repo. So in this case, I'm just going to go ahead and get a workspace ID using the API. I'm going to list if there's any run that is currently happening on the workspace. So basically, if we execute a run and there's already something that's running, your run is going to wait until all the previous runs can finish, right? The next step is to pass in the value that users input into the workspace variables, and then we create, and when we kick off a run and watch it for its status until its completion, right? In terms of the API, so basically if I go all the way up here, you can see there are many functions such as get workspace ID. This is very similar to the shell script that I showed you. Basically, the APIs are the same, passing it bearer token, using the same endpoint, and then I parse the content. In terms of variables, inputting variables, there's also an API that you can call, which is you need to indicate the workspace. You need to use the ID that you obtained before, and simply append /vars in there to get all the variables that are declared in the workspace. And what you get is basically a map of the key value pairs for those variables, and then you can assign them accordingly, right? Just one more example of the workspace and API that's API related. So here is a function that lists all the runs that are happening. Again, I'm calling a workspace, pass it in the the ID, and then here I indicated all the runs that are that I want to query that are still running, basically. So the rest of these functions are just compositions of all the Terraform API. They are, as I said, this documented, and you can compose them to automate the pipeline. So let's go ahead and kick off this this pipeline. That's my organizations, and going to give it a VM name, the VM type, and then just build it. So it will go out to a vault, get a token, list the run on a workspace, get the ID first, pass in the parameters, start the run, and now we are waiting for that particular run. And you can see the indication, it is in progress. I'm kind of printing the status of that. It is in the planning stage. So if we go into to our workspace, you will see planning was executed, cost estimations and policy check. Everything's passed. All I need is to confirm the planning and go ahead with the execution. And shortly, we'll see that successful completions also reflected in this pipeline. Okay, all right, that's, I think we are almost at the end of that process. And there you go, it's successful. And also should be reflected in the workspace. So that is basically my brief demo. Let's go back into my presentation again and wrap this thing up. So there are a lot of clients and libraries that support this, the Terraform version 2 API. To start with, there's an official Go client library. There are a lot of libraries also in other languages like Python, Ruby, .NET, and this is basically a testament of our rich Terraform community, right? In terms of utility, there's plenty. One utility that I can recommend to you is this TFX Rocks. It's a command line tool that wraps the API. The client supports both cloud and an enterprise, and you can use it to query various aspects of your workspace, your modules, and registry, right? By the way, this is written by the head of our professional services here at HashiCorp. And lastly, there's even more integrations from basic tools. You can use Google Forms, Google, Google Sheet to commercial offerings like a ServiceNow. Utilize the API to make the integrations with the Terraform Enterprise or Terraform Cloud. So with that, I think the message here is that workflows, not technologies, is our foundation. So this mantra guides our vision, our roadmap, and our product design. As you're evaluating HashiCorp products, it may be helpful to understand our intentions. So we want developers to get the most out of this technology, harness the power of a Terraform platform, and drive the consistency in the infrastructure automations. At the end, your technologies may change, but your goals stay the same. So with that, I'm going to end my presentations. Thank you for your attentions, and feel free to reach out and ask questions. And also appreciate if you can give me feedback. Thank you. Over to you, Kelly.
Great presentation and demo. Thank you.